What's up, everybody? Joe's Dad back again for another video lesson in our Chapter 7 video series. This particular lesson is on Section 7.6 from our textbook, or common logarithms. Okay, so what you will need for this particular lesson is a notebook or some sort of paper to take some notes on and do some practice problems. And we will get into the lesson right away. So if you've not done this before, or you have, I pretty much say the same thing every time. Please feel free to pause, rewind, fast forward, skip around on this video. Use it however you see fit. Maybe I do a problem and you didn't really get all the steps, and you need to go back and watch me explain that problem again. Use this video however you need to use it. Okay, so common logarithm 7.6. Here we go. So what is a common logarithm? A common log is what we call any log that has base 10. Any log that has base 10 is called a common log. Base 10 is the common base, and remember that when we see common logs, okay, or base 10, we don't actually even have to show. I'm just making something up, okay? Log of 80 would be log base 10 of 80. Remember that if you don't see a base here, you can assume that that base is 10. It's base 10, okay? And in 7.5, we learned something called the change of base formula, okay, or the way to change the base of something like this. Log base 8 of 85, okay? We can evaluate that two ways, okay? If you have one of the new operating systems on your calculator, TI-84 or beyond, you can just type this in log base 8 of 85 straight into your calculator. I'll show you how to do that, okay? So there's a couple ways to get to log base. I do alpha F2, and then it's option 5. If your calculator doesn't have that, okay, another way that you could get to that is, let me clear that out. You can go to math, and you can go on the math menu here. You go all the way down to option A, which is log base, press enter, and you get that same kind of skeleton formula. So you type your base as 8, and then you are evaluating the log of 85, press enter, and you get that that log is approximately 2.136, and this class will round to 3 decimal places. So 2.136 if I evaluated that on my calculator. Now, change of base was a way that back in the day when these graphing calculators didn't give you that skeleton log that you can change the base. The only button you had that you could use was this one down here on the left. It was just the simple log function. Well, on the calculator, when you hit that button, it assumes that it's a common log, base 10. So we had to learn, back in the day, we had to learn how to use the change of base formula to be able to evaluate log base 8 of 85. Okay? So the way that we learned last class to rewrite this is we could do log base 10 of 85 divided by log base 10 of 8. Again, we're going to use common logs to evaluate this. So now we can go to our calculator again. We can type simply log 85. Remember to close that parenthesis and then divide that by log 8. And if we press enter, we get, as you see, you get the exact same approximation, 2.136. Okay? All right, so set your calculator to the side for a minute. Let's keep moving. Okay, here is what will happen, or what some of the problems will look like. Okay, so example 1 says solve for x using logarithms. Solve for x using logarithms. Okay, so there are actually two ways that we can approach this problem. Okay, the first way to approach this problem is we can rewrite this as an exponential. I'm sorry, as a log function. It's already exponential. Okay, so if we rewrite that, it'd be log base 4 of 112 equals x. So then very clearly you can see all I have to do at this point is evaluate this log in my calculator using one of the two methods. Okay? Using one of the two methods, I'm going to do change of base. So I'm going to do log of 112 divided by log of 4, and I get an approximation for x that is approximately 3.404. Okay, that's one way to do this. The second way to do this, and this is what the textbooks actually shows you how to do, okay, is the textbook says, so if you have an equation, you can actually take the log of both sides, assuming that you use the same base on both sides. So basically, what that means is it says, okay, for the x equals 112, we can take the log of both sides of that equation. Remember, when we are dealing with equations, we want equality. Whatever you do on one side, you should do on the other side. So we can evaluate the log of both sides. Well, then what happens here is we can use a 7.5 property, the power property, and look at this exponent x. We can slide that out into the front as multiplication. So it's x times log 4 equals log 12. And then to solve for x, we just divide both sides by log of 4. And there it is. That's just the same log that I had the first method, just evaluated using the change of base formula. So again, that would give us our same approximation, 3.404. So that's two ways to do this problem. You'll find in mathematics a lot. There's many ways to skin a cat. There's many ways to get your problem solved. Here are just two ways that you could do this particular problem. Okay. All right, let's look at another one. Okay, example 2 is solve for x using logarithms, but here what's changed is we have x's on both sides of our equal sign. X's on both sides of our equal sign. So this is going to be a problem that we're definitely going to want to take the log of both sides. Okay. Remember what we just talked about. Mathematically speaking, you can take the log of each side of an equation just so long as you use the same base on both sides. So it's base 10 is by far the easiest base to use. So if we take the log of both sides, here's what we've got. And then on each side, both the left side and the right side, I can apply the power property and bring the exponent, x plus 1, out in front of that log using multiplication. And I'm grouping that in parentheses, by the way, just to make sure that I don't get confused with what's being multiplied by what. Okay, so now here's what we've got. We've got x plus 1 times log 3 equals the quantity 2x minus 3 times log 8. Okay? Now, here's what you got to realize. Log 3 and log 8, those are actual real numbers that we could find by punching it into our calculator. So typically what we want to do next is we want to try to get the x's on one side of the equation and then get everything that's not an x on the other side. So here's how I'm going to do that. I'm going to do some division here. So I'm going to take this 2x minus 3 and I'm going to move it to the other side, to the left-hand side, by division. So that's going to be x plus 1 stays where it's at. And if I divide both sides by the 2x minus 3, I get that over here. Now, if I want to move the log 3 to the right-hand side, I'm going to use division again. So I keep that log 8 on the top, and I divide that by log of 3. Now, if you're struggling with the algebra that happened there, pause just for a minute and ask yourself the question, if I cross-multiplied this equation, what would I end up getting? Okay, and if you cross-multiply this equation, you would end up getting exactly what we just had. We've just basically rearranged this equation. So now we have our x's on one side, and we have our constants on the other. So at this point, let's go ahead and let's evaluate log 8 divided by log 3. So I'm going to go back to my calculator, and I'm going to do log 8 divided by log 3, and approximate that to 3 decimal places. So I have x plus 1 over 2x minus 3 equals 1.893. All right, so now what we're going to do is, get rid of that. Now we are going to work on solving for x. So now I'm going to actually take this 2x minus 3 and I'm going to multiply it to the other side. So let's come up here. So I've got x plus 1 equals 1.893 times 2x minus 3. Now 1.893 is not a whole number, but you can still use the distributive property just like you would any other time. So 1.893 times 2, 1.893 times 2 is 3.786. So let me actually move this over here for just a minute. So it's 3.786 minus, I'm sorry, don't forget your x, minus 1.893 times 3. Uh-oh, gotta get the times there. Times 3. I get 5.679. Okay. So now I'm ready to actually do a little bit of work here. So let's add the 5.679 to the other side. So that becomes 6.679 when I combine that with the 1 that's already over there. And then I'm going to subtract 1x from the right-hand side. So that becomes 2.786x. And then finally, x is going to equal whatever 6.679 divided by 2.786 is on my calculator, and I get 2.397 for x. 2.397. Now, as you take a step back, you might be discouraged. You're like, Koza, these numbers are super ugly, and you're right, they are pretty ugly. Okay, but if you go back and look at the actual algebra you were doing, there's not that complicated of algebra taking place here. So don't let the presence of kind of ugly decimals deceive you into thinking you're doing something hard. It's very basic, simple algebra. You're just using some decimals. Okay, so if you're careful with your place values and your rounding and you're organized with your work, you won't have any problems with this whatsoever. Okay. All right, so let's try another problem. Example 3. So now we're looking at how do we solve inequalities. Okay, so how do we solve inequalities? So it says solve for x using logarithms. Okay, now we don't have an equation anymore. We have an inequality. Now the first step here is going to be the same as what we were using for equations that we just solved. We're going to take the log of each side. So that's the log of 5 to the 2 minus x less than or equal to log of 10. Okay? All right, so what I can do is I can take 2 minus x and slide that out in the front using the power property of logs. So that becomes 2 minus x times log of 5, which is less than or equal to log of 10. Okay, so now we are going to want to get our log, divide both sides by log of 5, so that becomes 2 minus x is less than or equal to log 10 divided by log 5. So now we're going to pull the calculator back out. Okay, and we are going to type that in. So we have log 10. Oh, but we know what log 10 is. I shouldn't have to do that on the calculator. Log of 10. Remember, if the bases are if the base is the same as what you're taking the log of, we have a property of logs that we learned last time that says that just equals 1. So that's 1 over log of 5. So that makes it a little bit easier for us. 1 divided by log of 5 gets us 1.431. So here's where I'm at now. I've got 2 minus x is less than or equal to 1.431. Okay. So then I'm going to get x by itself. So we have x. Let's bring this up here. We have, I'm going to add x to one side. Okay, and then subtract the 1.431 from 2. So let's do 2 minus 1.431. Okay, and we get 0.569. So we have 0.569. Let's minimize that. And then we've got less than or equal to x. Okay? So there we go. Final answer. So the only thing that changed here is instead of having an equal sign, you have an inequality symbol. Okay? All right, let's do one more together. This time we're going to look at what happens when you have a x on both sides of the inequality. Again, this is super similar to example 2 that we did a few pages ago. So we'll start by taking the log of both sides. So log of 2/3 to the x plus 4 power is greater than log base 10 of 6 to the 3x. You probably know what we're going to do. We're going to slide those exponents out in the front using the power property. On both sides. So now remember we're going to do some of that cross multiplication here to get these values to be on both sides. So we have x plus 4 over 3x. And we have if we divide both sides by log of 2/3, now this is a little tricky here, okay? Because when we divide both sides by log of 2/3, log of 2/3 is actually a negative value, okay? So that's going to flip the inequality sign, because remember, anytime you divide by a negative, you need to flip the inequality. So we've got log 6 divided by log 2/3. Okay, and if you're like, how did you know that was negative? Okay, well, if you type it in log of 2/3, you get a negative you get a negative value. So remember, the reason that sign flipped right there, for those of you that are tripped up by that, it's because the log of 2/3. Remember that log of 2/3 is an actual real number that has a real value that you see here. Okay, it's a negative number. That's why the values need to flip. Okay, so now let's figure out what log 6 divided by log 2/3 is, and I get negative 4.419. So here's where we're at. We've got x plus 4 over 3x is less than negative 4.419. Okay, so let's move this up over here. So I'm going to multiply both sides by 3x. So I'm going to take that value that I have on my calculator, and I'm just going to multiply that by 3. And I'm going to get negative 13.257. There's an x on that. And that's still greater than x plus 4. So then I would add the 13.257x to the other side to combine it with the 1x that's over here. So that's going to become 14.257x is less than, move the positive 4 to the other side to give us negative 4. And we are so close. Now we need to take x, or solve for x. So we're going to take negative 4 and divide it by 14.257. I get x is less than negative 281. X is less than negative 0.281. Okay. Again, guys, this is a little spicy here, but the only thing that made it complicated is the fact that we've got some ugly decimals. Okay, and you have to be pretty quick and pretty good with algebra equation solving skills to be able to get some of this. But I don't think this is beyond what you're capable of. Okay, so example 2 and example 4 were a little tricky because there's multiple steps happening there. again, if you need to go back and rewatch either example 2 or example 4, I bet you the second time you do it, literally work it out on your own and on your paper, step by step with me as I talk you through the steps. I think if you do it a second time, I think hopefully that light bulb will turn on and you will realize this isn't really as difficult as it might appear. Okay? So that's actually everything that you need from 7.6. You're ready to work on your homework for this assignment, or for this section, and that's all for me. I'll see you next time.